Okay, Wildcats. Today we're going to 5 play ball, absolute value equations and inequalities. All right, I'd like you to work questions 1 through 4. All right, now that you've worked those, let's take a look at the next page. Opposites attract, absolutely. You can solve many absolute value equations using inspection. Graph the solution set of each equation on the number line given. Okay, the absolute value of 5 is 5. The absolute value of negative 5 is 5. So when you graph the solution, your solutions are negative 5 and positive 5. All right. The student's going to work B. So if y'all would, you're the student, so go ahead and work B. Let's take a look at C. The absolute value will never equal negative numbers, so this is not equal, so there's no solution. All right, the absolute value of X equals 0. There's only one point, and that is at 0. All right, let's take a look at number 2. Write the absolute value equations for each solution set graphed. Okay, so we know that the absolute value of negative 1 equals 1, and we know the absolute value of 1 equals 1, so the absolute value of X equals 1. All right, student works B. Yes, student, so go ahead and work B. All right, now let's take a look at the next page. Activity 5.1, creating an absolute value function from a situation. The official rules of baseball state that all baseball is using during professional games must be within a specific range of weight. The baseball manufacturer sets the target weight of the balls at 145.045 grams on its machines. Sketch a graph that models the relation between a manufacturer's baseball's weight X and its distance from the target weight Y. Then write an absolute value equation to represent the situation and the graph. So we're actually going to do this first. We're going to write the equation and then graph. So the equation would be the absolute value of X minus 145.045. All right, so let's go ahead and use Desmos to graph that. So we're going to Math Tools, Graphing Calculator. Let's get that out of the way. All right, so we need this out of the way so we can get here. We want the absolute value, which is right here, X minus 145.045. All right, we don't see the graph, so we're going to zoom out. And we're going to zoom out to 145 on the x-axis because that's where our graph is. Okay, so we know we have that point, so let's go ahead and graph that first. So 145.045, well, that's about here, somewhere between there. Okay, now we need to kind of find some points on here, so we'll just track along, see if we can find a good whole number of points. That's probably as close as we're going to get to a whole number point is 85, 60. So let's it's probably a good idea to make a table to record our values. Okay. So 85. Now, here's the problem. That's not a bad point, but the graph on the paper starts at 138. So we're probably going to not use that point. Not a bad point, but we want to use something between probably 138 and 150. So let's go back to here. So I'm going to come down. Let's see what 138. 138.7, that's probably going to be a good point. So let's use that. 138, comma 7. Okay, so 138. 7 is about right here. Okay, and then we're probably looking at 146, 148, or 150 as a point that we can use. So let's come back to our graph. So that's too far, so we're going to come down. Let's see. 150, that rounds pretty much to 5, so 150, comma 5. Let's go ahead and use that. And don't forget, we had this point 145.045, comma 0. Okay, that was that point. Want that in the middle. So then 155 is right here. Okay. All right, go ahead and finish up the graph and table. All right, let's take a look at number 2. The specific weights allow for a difference of 3.295 grams in the actual weight of a ball and the target weight, since the weight must be within a distance of 3.295 grams from the target weight of y equals 3.295. Graph the equation y equals 3.295. So let's go ahead and graph that on here. Okay, and so we have that. And I'm going to zoom in kind of to the window we're kind of looking at around there. Okay, so when we graph it on paper, this is 3. So 1, 2, 3. 3.295 is slightly above that. And you don't have to, but it might not be a bad idea to color code your graph so it's easy when you're back looking at your notes. So let's go ahead and do this in yellow. Okay. And then I'm going to do the y equals in pink. Okay. Don't have to, but color coding tends to help so you can see this is here, this is here. Okay. So now, what 2 equations can you write without absolute values to show the least acceptable weight and the greatest acceptable weight of the baseball? So that's going to be x minus 145.045 equals positive 3.295, and x minus 145.045 equals negative 3.295. Now, write the solution to the equations you wrote in part B. So we're going to solve that. Let's do it algebraically. So to do that, we add 145.045 to both sides. This becomes 0. You get x equals, we can open up another tab for Desmos. And we'll wait for Desmos apparently to load. There we go. I'm going to Math Tools. I want Scientific Calculator. So we're going to add 3.295 plus 145.045. And that's 148.34. Okay. Now here we're going to add 145.045 to both sides. this becomes 0. You get x equals, and I can just come over here and change that to a negative, and then that's 141.75. Okay. Now you can use the graph and find the points of intersection, and there's your solutions that way as well. Okay. All right, so let's take a look at the next page. All right, activity 5.2, solving absolute value equations. The two equations you wrote can be represented by the linear absolute value equation, W minus 145.045 equals 3.295. To solve any absolute value equation, recall the definition of absolute value. Let's take a look at this worked example. Consider the linear absolute value equation. Absolute value of A equals 6. There are 2 points that are 6 units away from 0 on the number line, one to the right of 0 and one to the left of 0. So you have positive 8 equals 6 and negative 8 equals 6. So 8 equals 6 and A equals negative 6. Now consider the case where A equals x minus 1. The absolute value of x minus 1 equals 6. So you could say that x minus 1 equals a positive 6. And you're actually going to say this. You want to say x minus 1 equals a negative 6. Okay? All right. So we're not going to worry about questions 1 and 2. Let's take a look at the next page. All right. Let's solve each absolute value equation. Now, I don't feel like there's enough room to do this here, but you might be able to make a space. I'm going to go ahead and use an extra sheet of paper to do that. Okay. Now, we have absolute value of x plus 7 equals 3. We really have x plus 7 equals 3. You actually don't need the parentheses. And x plus 7 equals a negative 3. Okay, so now we solve. So we subtract 7 from both sides. So x equals, that becomes 0, negative 4, and subtract 7 from both sides. That becomes 0, x equals negative 10. All right, go ahead and finish up 3a. Let's take a look at 3b. So we have x minus 9 equals 12. So we have x minus 9 equals positive 12. And x minus 9 equals negative 12. So we add 9 to both sides. X equals 21. Add 9 to both sides. X equals negative 3. All right, go ahead and finish up 3b. Let's take a look at 3c. So we have 3x plus 7 equals a negative 8. And 3x plus 7 equals a negative 8. Okay. So we subtract 7 from both sides. This becomes 0. You get 3x equals negative 15. Divide both sides by 3. X equals negative 5. Now here, when you multiply negative by negative, that becomes a positive 8. So when we subtract 7 from both sides, this becomes 0. You get 3x equals 8 minus 7 is 1. Divide both sides by 3. X equals 1/3. I go ahead and finish up 3c. Now, here we have 2x plus 3 equals 0. So 2x plus 3 equals 0. And 2x plus 3 equals negative 0. Well, you subtract 3 from both sides. 2x equals negative 3. Divide 2 by both sides. That becomes 1. X equals negative 3 divided by 2. Well, negative times 0 is just 0. So when you subtract 3 from both sides, you get 2x equals negative 3. Divide both sides by 2. X equals negative 3 divided by 2. So really, when it's equal to 0, you don't have to do this. You can just set it equal to 0 because you'll see that the value is going to be the same and it's just going to be that number. All right, go ahead and finish up 3D. All right. So we've done those. We're not going to worry about this except for we're going to solve this equation. Now to solve, you have to isolate the absolute value first. So we're going to add 4 to both sides. So you get the absolute value of x equals, that becomes 0, equal to 9. So then you said x equals to 9 and x equal to negative 9. And there are your solutions. All right, let's take a look at the next page. All right, the student's going to work. You're the student, so work 5A, 5B, 5C, and 5D on your own, and have a wonderful Wildcat